Yes, it's recording. Okay, so I'm not a Zoom expert. I've added Tim into the breakout room, but the last time I clicked open all rooms, it automatically sorted everyone in there.
Okay, let's try this. Do you mind making me the host? Then I can try shuffling them in and out.
Sure, I made you a co-host. Does that do it?
No, I think only the host has the option to control the
Okay.
breakout room in that sense.
Yes, you got them.
Okay, perfect. So I think I'm gonna put, is Delaware ready?
Did you say University of Delaware?
Yep. So I'm gonna put you guys in a breakout room with Tim.
Have you made a breakout room for us?
Yeah, I'm putting you guys in 1 second. Okay. Am I missing anyone from you, Del? Oh, Neil Garrett. Okay.
And I believe that we've solved the technical difficulties. Hi, everyone. My name is Paul Stiles. I'll be your MC for today at the AICHE Mid-Atlantic Regional Conference. If you have any questions about the Virginia Tech car, I'd be more than happy to talk about it. And then when the teams have a lighter load, either battery construction's finished or they have some free time to talk about their car, I'd love to ask them some questions. But yeah, I also don't know how many of them can actually hear me. Whether it be the mask or them intensely working right now, but yes.
You are coming through okay, so Paul, keep going.
Great, thank you, Robert. But yes, at Virginia Tech, we're having a lovely rainy day. That's what's to be expected at Bleaksburg. I hope the weather's better in your neck of the woods, wherever you are. But yeah. The Virginia Tech car is, we have multiple reactions that go on board. I believe we have a vitamin C clock is the main reaction. And I think it is either a nickel air battery or some other alkaline non-rechargeable battery that is on board the car right now. And that's currently undergoing construction. Yeah, we also have a slow step, which is where the car is able to slow down to minimize air propagation. It's really cool. Hopefully we'll get to see it in action if everything goes to plan. Yeah, and any teams available that want to talk about their car or university, food they ate.
Well, actually, Paul, do you mind? Are you near the track at all, or like the working station up Pit? Maybe you guys can show us around.
Yeah, I can show you around the track. Oh wait, give me 1 second. 1 second, but yes, yes, that was my team lead telling me that yes, we can go walk around the track. I just have to get some of the proper safety equipment, and I can show you around what's going on at Virginia Tech.
Okay, I'm gonna make you the spotlight view.
Okay. So yes, as of now, I'm in I believe this is Hancock Hall. It's a nice, spacious building named after one of the philanthropists that donated a ton of money here. Our lab that we work in is the UO lab, or Unit Operations Lab, and I believe it was donated by Philip Morris. If I can get through. West Vaco Chemical Analytical Laboratory. Here's our lab that we're currently running on, and as you can see, the track is below, denoted by the tape. And Katie, do you mind telling us what you're working on?
Right now, we're building with our writers and reactions.
Do you mind pulling up the camera a little bit up, and then yeah.
Can you not hear them?
She's a bit faint. Yes.
Okay, let me get a little bit closer.
Okay. So right now we're building a curve for our vitamin C clock reaction. We go between about 4.3 ml to 6.5 in various increments. So we're just kind of preparing right now and then we're about to start.
Okay, sounds good. And yeah, let me get out of your way. Yes, this is the bottom part of the UO lab where all the chemistry magic happens. There's our car, there's Anshul. And then, there we go, all the cameras. And then I'll take you up to the upper part of the UO lab, which I'll show you where battery is working.
I'm assuming that's Virginia upstairs too.
Yes, that's the second half of the unit operations lab.
Okay. Do you guys have a distillation column that goes through like first floor and the second floor or something like that?
Yep, you can see it on my screen right now. Here, I can walk a little closer and show you guys. So yeah, here's the big boy, and
is this one that you guys are talking about? Yep.
Yep, starts all the way down and goes up second floor up through the scaffolding, and up on the second floor there's like a platform that you can work on.
Gotcha.
Yep. Hey, Lexi.
Hi everyone. Can y'all hear me?
Yep.
Okay. Well, welcome to the upstairs UO lab. Battery team's making the battery, and that's pretty much all that's going on up here. Okay. I might mute myself again then.
But yes, this is the battery team working on creating, or Lexi, what type of battery are you making? Zinc carbon, thank you. No, I thought it was nickel air for a second, but This is why you're the battery team leave and I'm not. Aluminum air. Okay. Yeah. But yes, that is all the lab Virginia Tech has to offer. It's a lot of fun, a lot of work, but it's worth it at the end.
Thank you for the tour, Paul. That was very engaging and very cool. Okay. Stony Brook seems a little busy, so I'm going to call on you, Pitt.
I don't know if the other teams have the ability to share lab. Time is a critical component of this competition.
Mm-hmm. Okay, so University of Pittsburgh, are you guys able to show us around your lab and show us your track? You guys are on mute.
Hello, can you hear me now?
Yep.
Hi, so I'm Nick. I'm the president of ChemiCar here at Pitt. This is Dr. Rodriguez. He's our safety inspector. And so we can give you a little walkthrough. I think on the other camera, you can see that we have a workstation, which is right over here. So you're going to see it both. So we have our teams working right now. And right now, one of our main things we're doing is we are making hydrogen for our hydrogen fuel cell. And we are double checking and confirming with our stopping mechanism, which is like a chemical circuit breaker. And then so I can also take you to our run area. So we are in our sub basement of Pitt, the engineering building. So we have our chemical lab over there, and we are using a long hallway to actually be our run time because that's where we have the space and it's close enough in proximity to our lab to allow another run between. So
are you going over the track right now, or?
Yeah, the track.
Okay.
So we can see meters take off. We have our starting box that we plan on using right there. We're gonna have our car, and then once the distance is set, we're gonna measure it out with a different color tape and have a line across, and we'll measure to that tape every time.
Okay, sounds good.
So that's the tour and where we're operating today. Does anyone have any questions or need anything more from us?
No, I don't think so. I think can you just show us your workstation, because I do see that there is a pit 1, but I'm not really sure where everything is. I guess I do see the car.
Yeah, now pit 1 is spotlighted. So car's in the back. Right now, the hydrogen is being made in that balloon, which we will use to propel our car and, confirming with all our stopping mechanism stuff. So we have a designated work zone and a designated, essentially standby zone and a designated run zone.
Okay, sounds good.
Is that?
Yeah, that was very engaging. Thank you.
I have a few questions for Pitt, though. More out of curiosity than anything. More out of curiosity. But how are you guys generating your hydrogen?
I can take that. So we're actually doing an electrolysis reaction. So we're splitting water into hydrogen and oxygen with an electrical current, and then the hydrogen will congregate at the anode, and then the oxygen at the cathode, and then we're collecting that in balloons.
Very cool. Is there any other interesting components on your car that you'd like to talk about? We don't have the ability to go over posters, so.
So just a brief overview. So we're using a fuel cell for the propulsion mechanism, and then our stopping mechanism is, Nick said, a chemical circuit breaker. So all that is we're treating it as a dead man switch. So we have a strip of magnesium that has electrical current going through that, and we're measuring the voltage that goes through that circuit. And we suspend the magnesium metal in hydrochloric acid, and a single replacement reaction occurs between that and the metal. So eventually, over time, the circuit breaks when the metal erodes, and then that's actually what triggers our car to stop. So if you see the table in the front on our Pit 1 camera, that's what the team up front is working on right now. They're doing a little bit of testing with that.
Wow, that's a very cool reaction that's going on. Good luck on your guys' competition.
Thanks.
Thank you.
Okay, so I think Tim Raymond is done with UD and they are good to go. So I'm going to assign Virginia Tech next. I'm still waiting for Neil Garris to leave the room. And thank you, Pitt, by the way, for the insight as to how you guys are generating hydrogen. Neil closed his laptop. Can you reboot him yourself? Yeah, that's what I'm trying to do right now. Thanks, Josh. It's like there's a countdown, so I have to wait 15 more seconds now. Okay, sending in Tim and Virginia Tech. Paul, are you supposed to stay outside?
I mean, I'm technically not a part of this competition.
Okay.
Although I've worked on the car.
Okay.
I'm hands-free.
Okay.
So hopefully nothing goes wrong with the electricity. Yes, if all of University of Delaware is out, I'd love to hear some information about either the lab or the car.
University of Delaware, do you guys mind showing us around your track or your workstation?
To see your workstation.
Well, we're having a little bit of reverb.
Sorry, we have a bunch of computers on and the sound. So yeah, you said you wanted to see our workstation and where the car is going to drive. Yeah, okay. So we have one table here that we had to clear some stuff off before, but this is one table. We have another table here. We have to bring one here.
Am I chasing you around with this camera? What am I doing?
Oh, no, sorry. We have our solid waste here, if you want to see that. Liquid waste is in the corner over here. Right here. And then I guess we have our sink here.
I'm not going to get an Emmy for directing
We have
anytime soon.
our like biolog station and stuff over here. I guess I can bring them out to the car track, right? You're getting to tour the best building on campus right now.
And my safety glasses fell off as I left the room. That's awesome.
That's perfect. Hey, safety first.
They know.
No, we can't go right. We're in that hole.
That way?
Sorry.
Sorry. And hopefully my connection stays on as I hop from router to router.
Yeah, hopefully. Nothing bad going on.
Well, I guess it's a test run for later, because you do need the connection to stay on when you walk over.
Right.
So good testing for it.
Exactly. Better to do this now.
Yeah. What hall are you in? As it's the best of Delaware, I'd love to know.
This is Colburn Lab,
Yeah.
named after Colburn
Pete
himself.
Chilton Colburn analogy.
Right, the distillation researcher.
Very cool.
Early.
This is our prompt at the hallway around which we're about to
We're
start.
about to mark up.
We're about to mark up literally right now to start for the distance.
Lines.
As of now, there's conveniently stickers every 6 feet.
Yeah, there's that too.
Walk our way through.
Or measuring tape.
Yeah. Is there anything else specific that you want to see about our like workstation or track?
No, I think we just wanted like a general like tour of your area. That's all.
Perfect.
Cool.
How wide is your hall?
Oh, we'll probably have to measure that right now.
There you go. It's like you gotta keep measuring everything.
Start from the 0.
It's about 2 meters, 6 feet, just under 2 meters.
Okay, thank you.
No problem.
And Delaware, if you have a little bit of time.
Pretty much.
I don't know what he said.
Oh, Delaware, if you have a little bit of time, I'd love to hear a little bit more about your car, whether it's the stopping mechanism, power, control system, anything you got.
Here, do you just want me to?
No, this is fun. I am enjoying this.
So we're getting you to go for it all throughout the hall.
As we're talking about it, I'll be walking. So the power comes from a zinc air battery.
May have lost a little bit of connection.
Oxide to as our electrolyte, and then our stopping mechanism, we have an acidic solution and a collagen capsule that you would fill with like supplements that you might buy from the store, and we have sodium bicarb that goes in there, and once the acidic solution eats through the collagen capsule, it'll reach the sodium bicarbonate and cause CO2 to evolve, and then we have a micro pressure transducer on the car. And it'll detect the change in pressure in our clock reaction and then tell the car to stop by switching this relay to off.
So now I can see on that other computer what I'm pointing at.
Oh, let's go in.
Yeah, let's point one at another. No, let's not do that.
Get an infinite mirror going on. Oh, thank you for the information. That's a very unique idea using the collagen capsule. Love to see the innovation.
Yeah, thank you. We love having fun clocks. East clock. That was pretty fun.
I mean, we're still on the main thing, aren't we? I feel like I'm directing the Bourne supremacy or something. Cam going on. I'm gonna set this down.
It's okay. I'm gonna take you off the spotlight view. Don't worry. Okay. Who else is next? Stony Brook. Do we call him Stony Brook yet? No, I don't think so. Stony Brook, are you guys able to show us your workstation and your track and give a little description about your car? Can you guys hear us? Oh, there we go.
Hello, can you hear me?
Oh. Yep, you guys might need to lower the volume on the other modes that you guys are joining the call from, so we can cancel out the reverb.
Is that better?
Yep. Much better.
Okay. All right, so this is basically our workstation. Right now we're just sanding the iron anode plates that we're using for our iron air battery. So taking wool, and I'm also in the process of wrapping them in coffee filter paper, which acts as our electrolyte when we pour our KOH solution on it. And this is basically our car. So, yeah.
Do you guys mind showing us your, or going over how the car actually works, where everything lives?
Yes, so we're currently preparing the iron sheets for our iron air battery, which will be housed in this container here. Besides that, we'll also be running a luminol chemiluminescence reaction as our stopping mechanism. And I'm running this reactor up here.
Okay. Awesome. Do you guys mind going over over your track and just showing us around a little bit?
Yeah, no problem. For the time being, we just decided to use the hallway as a track, since it's the closest area that has access to spill kits, all the emergency equipment that we would need.
Perfect.
So this is the starting line, measured out to 15 meters.
Because I'm realizing a common theme. Whenever students are walking around hallways, the Wi-Fi goes out a little bit.
Routers can only provide so much distance.
Yeah.
But hopefully, when everything is set up and stationary, we shouldn't have this issue.
Yeah. I mean, it looks like everything is marked, so. Oh, I think they completely disconnected.
Do we have any other visuals of the Stony Brook lab or anyone from Stony Brook that is still on the call?
No, actually, yeah,
Yeah, it seems we disconnected for just a second there. I apologize.
No, it's okay.
In general, we have this is our small workbench that we work with. All our materials are just housed in the back behind there with some chemical cabinets further down.
Gotcha. Thank you for the little tour and explanation of your car.
Thank you.
I have some more questions if you guys have any time.
Yes.
Sure. So is there any reason why you chose an Arduino as a microcontroller instead of like a PIC32 or Raspberry Pi?
These were the ones we had the most access to, since we're not very experts. We're not experts at circuitry. We don't have any electrical engineers on our team or computer science majors in our team currently. So we tried to go for the simplest, most direct method that we have.
No, it's a good call. We also run some Arduinos on our car. It's just wondering if there's any variety out there, or if everyone's doing the classic choice. And then, are you guys? What kind of motors do you have for your wheels, or and anything that you do there, or what makes your car unique?
I gotta say, our car is unique in only that it's we tried to save as much money as possible and also try to be as efficient as possible. Other than that, our motor is not very atypical. It's pretty ordinary motor that you'd find anywhere. I believe it's a 40 to 15 gear ratio. That was decided in assigned in the past, and we were running low on time, so we decided this would be the best fit for our car.
Yes, that's some great reasoning. That love of efficiency and optimization is going to serve you well in industry. Thank you for sharing about your car.
Thank you very much.
Okay, awesome. I think Virginia Tech is good to go. So I'm going to place the next team into breakout room with Tim. Udell's good. So Stony Brook, you guys are up next. I'm going to place you guys all in the breakout room. So in 15 minutes, just a reminder, you guys will know the distance and the order of the competition. I guess only one Stony Brook team is, or camera is joining the breakout room, but that's fine. I think the last team left is NJIT. NJIT, do you guys mind showing us around your workstation and your tracks?
You're gonna show?
Hello.
All right, so over here is our workstation. You see?
Yep.
Yeah. So this is where we mostly do our work. We also have our fume hood right over there. You want me to talk a little bit about the car, you said?
Yeah, that'd be nice. Yeah.
Okay, so we basically use a hydrogen fuel cell. We generate the hydrogen on board through an acid-base reaction. And then our stopping reaction is we use a photosensor that is blocked by a fiberglass. We plunge in acid, basically dissolves a strip that we have holding the fiberglass. Once the fiberglass falls, the infrared light hits the photosensor and then activates a relay switch that stops the car. Do you guys want to know more? Anything else?
I certainly would love to know more about your car. Usually a lot of them have like 3D printed components, and I don't see any on your car. It's you have access to a metal shop? Are you guys using a lathe?
So we've been working on some 3D modeling, but we haven't made any changes. We basically just used sort of like a basket, and we found that to be the best up to this point because we had some technical difficulties with the 3D printing. We basically took apart a toy car, like completely destroyed it, and basically just cut the chassis, cut the bottom, and we found that to work the best, to be honest.
Okay. And then what are all the gauges for? Like, do you have anything that reads them, or is it just for testing?
Yeah, so the gauges, basically, once we generate the hydrogen, obviously the pressure goes up, so we have all these gauges basically here, these 3 cylinders, which is where we run our acid-base reaction, to let us know, like, once we already know through the pressure when we have the sufficient hydrogen to run the car. And yeah, so obviously safety too, and then we actually have we have 2 valves that basically is to regulate the hydrogen going in, because we can't feed too much hydrogen into the fuel cell, otherwise it will damage it.
Yeah, that's a very complicated system going on. Do you have anything are you using computers to regulate it, or is it more lines of just good old-fashioned analog systems?
Yeah, no computers.
Yeah, no, that's a very interesting design. Looks very complex.
So do you guys want to see the track now?
Yes, that'd be great.
Okay. So here's our track. We're using a laptop. Well, you want to show them?
Oh yeah.
So here's our starting line, the blue line. Then we have marked every meter has a black mark. We have a mark at the tip. Do you want to come forward? We we have marked everything up to 10. Then we have a line here to let us know this is the 10 meter. And then we have another blue line over here that tells us where the 15 meter mark. Anything else you guys want to know?
I think that's all the track information. Any safety equipment that you guys have to show off?
Let's go back into the lab. Okay, so, but can you continue? So by safety equipment, are you talking about PPE?
PPE, any like acid or waste disposal, whatever you guys want.
Oh, okay. So yeah, so we basically, we all have face shields, we all have goggles, gloves, lab coats, long pack, everything long sleeve, closed toe shoes. Our chemical disposal is actually over there in our fume hood. That's where we don't generate too much waste, so we don't have very big containers.
Okay.
Yeah, nice to see an efficient process. Yeah, that's all the real questions I have. Anything else you guys want to talk about? Feel free.
I think I have a follow-up question if you guys don't mind. JIT, do you guys mind showing us your track one more time? I just have I just need to understand one thing. So you said you guys said the blue line is your starting point, right?
Yes. Yes.
And just for clarity purposes, I just want to understand which point of reference on the tape you guys are using for measurement. So I guess my guess would be that if we're looking at the tape, just the blue tape at the very beginning of the blue tape is where you guys would start measuring.
Yes. Yes.
And then the black tapes, it's the end that is closer to you standing now as the point of reference that you guys will be measuring. Does that sound right?
Yes. So
Okay.
we'll be using, so basically, yeah, the blue line is just to let us know if we're like sort of what distance we're getting without having to check every black tape, every meter basically. But yeah, we already had the black tape down that for every meter up to 30. But we just did the blue tapes yesterday to make it maybe a little bit easier for everyone to see.
Yeah, that makes sense. I guess like what's important is that we just use the same point at each track to start the measurement and then end the measurement. So we just got to keep that in mind that depending on where the car is beginning we have to use the same point of reference on the car when the car stops for measurement, just so it's fair for everyone.
Of course.
And not to single you guys out. I wasn't trying to do that.
No,
sorry.
no, that's okay.
Yeah. Okay, I think I'm gonna cancel the spotlight view on you guys. So I think Paul, it's okay to announce the distance in order now, because then Tim's safety check is done for Stony Brook and they're good to go. So we have everyone on the team on the call now, and then we can, after announcing the distance, we can send the other two teams in breakout room one by one.
Okay.
I'm actually going to be the one doing the distance.
Okay, that's fine.
But yeah, so if I can go ahead and do that now.
Yeah.
I'll share screen. Let me know when everyone can see my screen.
Yep,
I can
we
see
have
that.
Okay, so just before I announce everything, I'm going to walk through how this spreadsheet is laid out to ensure everything is completely random. So this is going to be for a distance between 10 and 15 meters. It'll generate a random integer between 10 and 14, and then a random decimal between 0 and 10, and then divided by 10. So I'll just be removing the apostrophe at the start of the formula, and that'll generate a random distance. For the order, I'll be removing this apostrophe, which will put random values next to each school's. I'll then copy those in place and then paste in just the values for sorting. The reason I do that is because otherwise when I sort them, the random values will all repopulate again and change. So just pasting those values in place, and then I'll sort them. And then these values on the left will give the order of the schools. So first, second, third, fourth, and fifth.
That's very fancy.
And then otherwise, I'll put all of the results in the chat in case there's any issues with transmission or people hearing me.
Sounds good.
Right, let's get started. So the random distance will be 13.7 meters. That is 13.7 meters. I'm going to change that value so that doesn't repopulate either. Next, for the order of the schools, generating random numbers. And you'll see that these numbers don't change when I copy them in place because I'm just pasting back in the values. Why didn't it work? Okay, never mind. I'm just going to order them like this then. I tried that like 5 times, but okay.
Yeah, do you mind sending me the spreadsheet with the logic later? I'm actually very curious to see how this works. I want to play around with it.
Okay. So then, why does it keep repopulating? Okay. I'm sorry, I promise I tried this like 6 times. But... Okay, so the lowest number here is going to be Stony Brook. That means number 1 is going to be, is it? Oh my God, it's repopulating again. I am so sorry.
Macros are a little bit of witchcraft. Sometimes they work, sometimes they don't.
Okay.
Copy those and paste them as a text.
That's literally what I had done the first time.
Okay.
And that's why I was like, why didn't this work? Okay, yeah, because see, these just updated again. Okay.
Then it won't, every time you make a change in the spreadsheet, it reruns it.
Okay. Now these are just values. Now when I sort, everything will work. Sort smallest to largest. This is our order.
Oh, Stony Brook is still first. Great.
Stony Brook first, Pitt second, Delaware third, NJIT fourth, and Virginia Tech fifth.
Great. Awesome.
I will go ahead and put that in the chat and stop sharing screen.
Okay. I think Paul also had an announcement, right, Paul?
Yes. I have an announcement for the winners for the poster competition. The first place award goes to Virginia Tech. The second place award goes to NJIT. And the third place award goes to U Delaware. Congratulations on your posters.
Thank you.
We missed what you said. Delaware camera 1.
I'll be more than happy to repeat. The first place goes to Virginia Tech. The second place goes to NJIT. And the third place goes to University of Delaware.
Let me tell you, we could have started like.
So good job, everyone, on your posters.
Okay, so I'm gonna wait for Tim to come back, and once he's back, I'm gonna put the next team in the breakout room. I think the only teams left are NJIT and UPitt. Okay, I can put the next team in. And UPitt, your name came first to my brain, so I'm gonna put you guys in first.
Perfect.
And do we have a time of when Stony Point, or sorry, when Stony Brook will begin doing the runs?
So the competition will start an hour from now, so at 11.
Okay.
Yeah. Thanks for joining, Dave. I wasn't expecting you to be on the call. So for everyone who doesn't know, Dave is also on the ChemiCard committee with Robert. So all the rule changes and all the different decisions are made with their consultation in mind. So, and we have to thank the ChemiCard committee for putting together a plan to how to run a virtual competition to make sure that from a safety perspective, it was, we don't end up in the news. So, yeah, this was possible because we got a lot of input from their expertise.
I think it's also possible because the teams have worked so hard to put this all together, and
yeah, for sure.
Staff also, Harpreet and Derek and Owen and others have really worked tirelessly to do this. Every weekend they've been working on this. So.
Yeah, I think there was a lot of interest from the team, so we couldn't just ignore that.
That's good.
Yeah. It's definitely been a team effort on everybody's behalf. So
yeah,
so true.
Good job, everyone.
Is Skip going to join later at 11? I'm assuming so, right?
That's why I came on. I figured, he's probably he's on the Pacific time zone, so it's a little early for him to get up. So
yeah, I sent him a note saying, basically saying that, if you just want to stay on call, that's fine. You don't have to join the call. But he was actually very interested in joining, and attending the Mid-Atlantic Regional. So
he doesn't want to miss the excitement.
Yeah, for sure.
Exactly.
Yes, there'll be a lot going on in about an hour. It's definitely going to be an interesting race this time around.
Yeah.
Sure.
And just as a reminder, Mid-Atlantic gets 5 qualifying teams. So technically, if your car runs and doesn't get disqualified, you guys proceed to the annual competition.
Harpreet, just a question for you.
Yeah.
We got a question from the Thessalonica team in Greece. Are they going to be participating in a Greek regional, or are they?
So to my knowledge, I did see that email yesterday. So there wasn't a ChemiCard competition in Greece. I'm assuming that their question was for next year. I don't think, I don't think they get a qualifying spot for the annual competition.
Because there was a Greek team that came last year to annual, right?
Right. Yeah, because that
was Athens that came.
Yeah, I think that's because we had an international ChemiCard competition there in Greece, and one team qualified and they came, but this year they didn't have a regional. So
okay. So they're talking about regionals for them, perhaps next year, and at least annual, or maybe annual. So.
Let me pull up your email. Sorry, I was gonna respond to you late last night, but I lost my wallet, and I was just like calling all my credit card companies and canceling everything. And
oh
that
no!
Yeah, it was a hassle, but it's okay.
Oh,
that's terrible. Yeah.
Yeah, and then I got a text message from Chase saying, someone charged $600 on your credit card at a CVS. Is that you? I was like,
how can you spend $600 at a CVS?
At a CVS.
Yeah. Wow. I think that's what triggered their fraud algorithm. But
I mean, what do you buy at CVS for $600?
A lot of potato chips.
Wow.
In the rules, it states that on site. Yeah, I think I'm assuming that they're talking about next year, because they don't get a qualifying spot. I think the only one that we got one from is Brazil, and I need to reach out to them. And I also have the contact information for those, so I can forward that to you as well, Dave. But
sure. Okay. Okay. Well, I think that just helps frame how we answer that question back to them. So,
do you mind copying me on the response that you send, so I can just follow up with just confirming that they are competing? They're talking about for next year and not in November.
Sure. Yep.
Yeah. Thank you.
Yep. Yeah. Well, my guess is if they're not coming to annual, then it's going to be, they have to run their regional probably first.
Yeah.
Okay. Yep. And I saw in your spreadsheet that Columbia competition dropped off. They're not doing performance.
Yeah, so they had one team competing, but I think also due to restrictions on their campus, they weren't able to participate. I think Western is also canceled and India is also canceled. So those are the three regionals that were canceled due to restrictions.
But they're doing the other competition as
yeah,
well.
Yeah, they're doing the other competitions.
Yeah, good.
We have did you know, Dave, we have 76 teams for Jeopardy in India.
Whoa.
Yeah.
That's incredible. I saw that number this morning. I thought, no, that can't be right.
Yeah. It's, I don't know how NIT, like that's the host university in India, I don't know how they will handle it, but that's a lot.
It's a lot. Yeah.
Yeah.
Good
it's
luck.
like a cricket game, you know, it's going to take like a week or two to go through all that.
Virginia Tech just hosted our Jeopardy game the other day, and I was also emceeing for that one too, and that was a bit of a hassle at points. And we only had, I think, roughly like 7 teams in total, but it was a lot. Factile was a little difficult, but it worked eventually.
Yeah, I think like all this is just a learning experience, so it's obviously a little bit of hiccups are bound to happen. You know, we've been doing this almost every weekend since late September, and we run into issues all the time. So I guess it's just, you know, just having a mutual understanding that we're all doing this the first time. You know, it's a learning experience. We rely on each other's cooperation, and that's how we're able to make a competition like this happen.
Yeah, it's a lot of moving parts, and I'm happy that everyone's willing to try to make it work.
Yeah, for sure. Okay, ready for the final team. So let's send in NJIT. Is that the last team left? Right? Yeah. Okay. recreate all rooms, assign. So NJIT, please be ready. And I'm assigning you guys into a breakout room with Tim Raymond, the Regional Safety Coordinator.
And since we have some downtime, I'd love to advertise some of the research that's going on with the graduate program here at Virginia Tech. We have a lot of opportunities ranging from biomedical and engineering to membranes and advanced separation. One of the labs that I currently work in here with a bunch of graduates is the Rajagopalan lab, where we work on tissue engineering, which can range from like 3D printing of cells to setting up cellular, I guess, cakes for back of a letter term, and then using it for testing as a way to mitigate animal testing. It's a really interesting lab, great people to work with. I have friends that are also in the catalysis and surface lab. Kareem, who is my catalyst teacher, is one of the head people in it. Does a lot of work with colloidal nanoparticles and microfluidics. We also have some membranes and advanced separations. The Deshmu lab focuses on computational methods of simulating how the atoms and molecules are working at the molecular level for said membranes or chemical reactions. And the Martin lab works a lot with interfaces and self-assembly and some chemical separation using filters. So a lot of opportunities at Virginia Tech. If anyone wants to talk about their university and what their graduate program looks like, I'd love to hear it. But also understand that all of you guys are working right now.
Paul, are you planning on pursuing a graduate degree or just looking for a job after finishing your undergrad?
That's a good question. Right now, I plan on going straight into industry. I do a lot of medical device prototyping. Like right now, I'm working with the Georgia Institute of Plastic Surgeons to make medical devices that have essentially disappeared thanks to COVID. A lot of commonplace materials have to get used as substitution or directly involved with treating COVID patients, whether it's on ventilators or if it's just testing. So it's really all hands on deck, and every resource needs to be utilized. And I've worked on creating a biopsy needle holder specifically for some of the tests done, or some of the blood tests done with COVID using my knowledge of 3D printing. I love it. I did prior to COVID. I worked with the Virginia Medical College to make a automated system for that could be essentially airdropped anywhere. It was to synthesize dolutegravir, which is an antiretroviral that is used in a cocktail to prevent HIV. And it was a machine roughly the size of a table that was meant to be automated, have essentially soldiers or anyone just push 3 buttons and dolutegravir gets created out on the other end. But yeah, it's I'm mainly focusing with medical devices. I love chemical engineering because you can do almost anything with the major. If I wanted to go into automation, that's a door. If I wanted to go with standard classical process engineering, also an opportunity. Or really any other major. We have a little bit of everything here.
Do you know what sort of a company you might want to end up at? Like, I know I have a friend who works at Regeneron in Albany area. I don't know where exactly, and he's in that medical prototyping department of theirs. And from what I hear, he loves it. So, yeah,
it's a lot of fun. As of now, I'd love to go back to MBC and work with them, and then depending on if I can spread out my own network, I may just start my own business and then create something on my own, just small time. But I like the freedom and idea of having more control over the workplace more than anything else.
Well, that makes sense. Yeah.
Yeah. And I've also had some really interesting co-op experiences. I worked with Albemarle Corporation. I was in Silver Peak, Nevada. It was roughly me and 98 other people at one plant site. I was 1.5 hours away from the nearest gas station and 2 hours from Yosemite. So I was really out in the boonies. But yeah, a great experience, a risk that definitely paid off, and I made a lot of good friends and good learning experiences along the way.
Yeah, it sounds like it.
Yeah, I'm trying to grab one of the other people either on battery or controls, whatever. We have a limited amount of people that can be in the lab at all times, given the space. So if one of them's out and relaxing, we're taking a breather. If I can snatch him for, I don't know, some sort of interview or more conversation, I'll hit you guys up.
Sounds good. I think just as I guess, not a reminder, but just let everyone know, I think we have a couple spectators from other regions. So they just wanted to stop by and just see how things were working here ahead of their competition, because obviously they haven't done anything like this before. So they just want to see what works, what doesn't, and how they can conduct a competition in their region.
Yeah, it's fun being the guinea pig. It's
well, yeah. I mean, I think you guys are like the 5th competition.
Okay.
So
I'm glad to know that this method has worked before for at least
yes.
5. That's very reassuring.
Yeah. Okay, I think I got the final thumbs up from Tim Raymond. It looks like all teams are good to go.
Hey, hold on.
Oh, okay. 1 second.
So we made our track like less confusing.
Okay.
So we wanted to show you the track.
Okay, sounds good. Here's your opportunity. Okay.
So basically, everything is marked from the beginning of the blue marker or the black marker. So the car is dropped here at the blue line, at the beginning of the blue line. And this is 0 meters, because our track was like starting from 1 meter before. It was kind of confusing. So we made it from 0 meters. So then like when the car comes to the beginning of the black marker for 1 meter, that's like 1 meter. Right, and then we go here. So whenever it reaches the beginning of the blue line, that's 10 meters. And whenever it reaches the beginning of the blue line here, it's 15 meters.
Yeah, that looks very detailed. Thank you for clarifying that.
Okay, thanks.
Dave, Robert, and Tim, do you guys mind hopping in a little breakout room with me for a second? I think we have a couple things to discuss.
Okay.
Yeah. Give me 1 second. Or actually 55 seconds. The NJIT team is in the breakout room, and I think it's not gonna let me kick them out right away.
Okay.
You could start a new breakout room, I guess, maybe.
Yeah, well, for some reason, like, it's
doesn't like you today.
Yeah.
I know that feeling.
You guys should have a join to the breakout room option or pop-up menu. So I'm going to be going with them. So Matt and Paul, you guys have the floor to control everything. We'll be right out.
Sounds good.
Sounds good.
Quick question from Pitt. Sorry, I was away from the computer. The first round is still at 11, correct?
Yes, that's correct.
Okay. We just saw people lining up, and we wanted to make sure we weren't missing anything. Perfect. Thank you.
You're good.
So Matt, can you hear me?
Yeah, how's it going?
Okay, great. Since we have some more time left over to talk, I know you're doing your co-op right now with Exxon, right?
Yeah, so I'm actually out in Spring, Texas right now. I'm on co-op with ExxonMobil at the campus doing process design engineering within their global projects company.
Okay. So do you have like any interesting experiences that you'd want to share, or like living on site? How's that like?
Yeah, so well, living here is very different. Texas from Blacksburg, at least, not as much wind, and it's a little hotter. And actually, the Gulf Coast area in Southeast Texas is a lot more humid. But it's weird right now. So I've been in rotations during COVID and not during COVID, and it's really different. Like right now, I'm working from home at least 3 to 5 days a week. So that's really different, trying to adjust to like the Zoom environment and Skype versus actually, you know, going into the field most days and actually being around the process equipment all the time. But in terms of experiences I've had, like it's been great. So this is actually my 4th rotation with ExxonMobil, and I've done 3 now in process design. So different designs for revamp projects around our different refineries in the Gulf Coast. And then also 1 in manufacturing, which was really interesting as well. Getting more into the day-to-day stuff, and also getting to do some contact engineering backfill roles at like site power plants. So learning about things like STGs, GTGs, and cogens, and how all of those principles work, and like refinery steam and fuel gas balances. So that was really interesting. That's what I was doing this summer. And then also working on some of like the oil movements on so like blending and then exports, so like to the wharf versus pipelines and whatnot. So lots of interesting experiences, lots of diversity across 4 co-op terms, but yeah, it's going well.
Oh yeah, I bet. No, and it's interesting to know that all the workflow is staggered, and that you're still able to do the same caliber of work even if COVID's happening.
Yeah,
that's crazy in its own right.
Yeah, it's interesting too, because typically a lot of the co-op projects here will be capital expense based. So like projects for new facilities, but for my last 2 terms, it's just been optimizations and improving the existing tools that we already have. So for like my work when I was at the Beaumont refinery this summer, it was all optimization based. So looking at where we can cut costs or minimize our lost opportunity by optimizing with no capital expenditure. And so it's different, and it's honestly fulfilling when you get to say, I found this improvement without spending any money. So that's cool. And then a lot of the work I'm doing this fall has been initiative based, so improving our tools for training new engineers and onboarding them in terms of different types of process equipment and unit operations. So that's interesting as well.
That sounds like it. Do you think you're planning on going into process engineering in the future, or is there any specific thing you like the most in chemical engineering?
I would say I really like process design specifically. So when it comes to like implementing new facilities, because there's a lot of like advanced process modeling that goes into that. I think when you're in a manufacturing role, a lot of your time gets dedicated to more equipment-based concerns in terms of things that could go wrong at a certain manufacturing site. But when it's process design, you really get to dig into like the chemical engineering principles of like fluid dynamics and heat transfer. So I really find those aspects really interesting.
Yeah, it's always nice to be able to put the theory into practice and see how it actually works.
Yeah, absolutely. It's also pretty cool when you finally get to see those principles you learned about in class applied. I'm sure you've seen that as well.
Yeah, I had a little bit of experience with that in my co-op. We had to look at brine heat capacity because one of the things that needed to be improved upon was how much lithium was able to get moved from one solution into another. And as you heat up a reaction, things go faster, but we need to figure out how much heat really needs to get moved inside of it to figure out the change in temperature. So I used what is it? That integral form of I think it's CCAT, Q equals CCAT. That's how I learned it in high school. And I was like, I don't think I'll ever use this. This is way too ideal of a system. But to a point, yes, the one we learned exactly in school. But with some minor calculus and modifications, it did a pretty good job of predicting lithium brine.
Okay, that's awesome. Yeah, it's always interesting to see how like there are always some like slight variations from the formulas you use, but like you understand what it's based in, and it's fulfilling, honestly.
Yeah, that and I had good luck with fluidized beds. A little over my head at the time, but I remember when I was taking mass transfer, we got back to the column separation, all that other sort of stuff, and I'm like, wow, I remember doing this in Silver Peak. I'm glad it's actually paying off.
Yeah. Yeah, for me, it was like separations was the big one. Like I had learned about the Cave-Thiele diagrams in my first term in process design, and I was like, I don't know what this is. I don't know what's going on here. Then actually learning about like operating lines and like your Q line and like calculating the different number of stages, I was like, wow, if only I had known.
Yeah. Glad to see that all that we're learning isn't completely useless. It's I may not do calculus every day, but algebra, no, pump the brakes on that. But yeah, Matt, are there any interesting skills that you've learned over quarantine? Whether personal or job related?
Well, I've become a Game of Thrones expert, if that counts. Yeah, so I've spent my last month on co-op binging the entire show, and I only have 3 episodes left. So.
Well, I hear they're very controversial, so I hope you enjoy them. I don't know the true outcome, but we'll see from there.
What about you? Any cool skills in quarantine?
Yeah, I've been focusing a lot on soft modeling. So if you think of CAD, that's hard modeling, which it cares a lot about the dimensions and having rigid forms. But soft modeling is more the organic kind of stuff. So one of the projects that I was working on was like trying to find a better way of supporting a structure, but with using less material and less weight, like in drones. So if you take advantage of what Mother Nature gave us in bones, there's a lot of really great support structures like hips and stuff that take advantage of their shape and design by using curves instead of edges to get the statics to work out really well with reducing material. So you can't really draw a bone in CAD. You can simulate how it holds up, but you can't draw one. So I've been using stuff like ZBrush and Maya which are usually associated with art in like the movie industry, like God of War or Call of Duty. All the models are made in ZBrush and Maya first, or any of the animated films by Pixar. They have the same workflow. So just utilizing the skills in a non-traditional manner and trying to 3D print cool stuff.
Mm-hmm. So are you just 3D printing, or do those allow you to like model forces and stuff too? If you're
yeah. So that's the real key feature of like Autodesk Inventor. It's not utilized in like, I don't know, general engineering, but the further you get in, at least on the mechy side of things, you get to simulate it like you could simulate a bridge or at least parts of a bridge and see where the strain and stresses actually are occurring. So it's not something you can do with the other programs, but you can always import the object file from one into another.
Oh, okay, cool.
Yeah. You're really translating a language from one code to another and hoping that they speak properly. But at the end of the day, it usually works out. Yeah, I also got a heads up from Jared that if he wants, if he can go over the poster, I'm gonna try to coordinate that out with him.
Perfect.
Yeah, I'm just pulling it up right now, and if someone can give me screen sharing permission, then I can just present the VT poster.
That may be Matt.
I lost my ability to edit screen sharing permissions when I handed over the host duties to.
And I don't know
Let's
if
see.
Harpreet.
Oh wait, did that work?
Yes.
Yeah. Okay. Cool. 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 See, present from the beginning. All right. So this year we named our car Corona for clear purposes. So my name is Jared Arfeld, and I'm the team lead this year. So we'll start with our process summary. And our car is powered by a zinc carbon battery, which you can see a picture of right here. And it's layered cells of zinc and then a sludge made of manganese dioxide. And so that powers the car. It gets around 19 to 20 volts. And our car is also stopped with vitamin C clock reaction. Upon reaction completion, we have a photodiode and a relay system that will cause the car to stop. So our run sequence begins after we depress our syringes, and we have 4 vitamin C clocks that are concurrent reactions on the car. And as soon as we depress the syringe, we press a button to start the car, and the car begins to move and follows a variable velocity profile. And once the 4 clocks have their color change, then it blocks a photodiode and relay mechanism to cut power to the motor, which quickly stops the car. So we don't actually have any brakes, but as soon as the power stops to the motors, the car stops pretty darn immediately. So if any changes are needed for the second run, then we vary the vitamin C concentration. And this is based on deviations from any expected chemical mechanical behavior. And we have modeling that we completed throughout the semester in order to accurately predict exactly the deviation and the correction that we need. So a couple of our unique features: our car uses 2 Arduino Unos to do any of the necessary calculations in the code and to control our motors and communicate between the various sensors. We have 4 separate chemical reactions, and this just allows us to increase the accuracy of the car. And really cool thing that we have is we have computer fans that we hot glued rare earth magnets to. So this functions as a stir bar, except it weighs about an ounce versus a couple kilograms like a normal stir bar. So our battery, like I said earlier, is zinc carbon. Here's the overall reaction. I don't want to talk through everything, but it is in this sealed plastic container. So if there's any leaks, then it'll be contained. The battery, of course, there's no liquid. It's a sludge of manganese dioxide and acetylene black. So there's not really any liquid in the car anyway. So here's our velocity profile that it travels. So it speeds up, drops down, stops. Our car weighs about 4.5 kilograms, so pretty heavy. It's 40 by 30 by 20 centimeters. And so earlier, 19 to 20 volts. Some of our safety features: for a zinc carbon battery, we have an acid resistant containers, and there's a pressure vent. There's no pressure that is evolved, but just to be 100% sure, we have the vent. And we all wear proper PPE at all times. If you've seen the video, we're all decked out in like 5 layers of PPE, so nothing's getting in. For our reaction vessel, they are beakers, and we have custom 3D printed reaction vessel caps, and this relieves pressure while preventing any discharge of chemicals. So if there's any splashes or potential leaks for any reason, then our caps will stop that. And we have compression fitting to prevent any leaks. So it's pretty tightly sealed. And for our electronics, everything is soldered and shrink wrapped to prevent any possible electrical shocks. And we use rechargeable batteries to power auxiliary car systems. The main processes of the car are, of course, powered by our zinc carbon battery, though. So for our stopping mechanism, it's vitamin C clock. And this is a color changing reaction that starts off as a clear solution. And once it hits a certain time that is determined by the concentration of the reactants and the temperature, then the reaction goes from clear to a really dark blue. And this is a precipitation reaction between starch and iodine, where it forms this insoluble complex. So you can see a curve between time and the volume of vitamin C in milliliters that we add to our solution. And here's just our list of reagents: so vitamin C, starch, iodine tincture, hydrogen peroxide, and DI water. And fun fact about that is we can buy them all at Kroger. So pretty innocuous and safe. And lastly, speaking of safety, we've taken a lot of extra precautions due to current circumstances. So we have face masks and face shields that are worn at all times in our lab. Students check into and out of the lab using QR codes for contact tracing. Luckily, we have not had any incidents. And we have hand washing and sanitizing is done frequently. We have like 10 bottles of hand sanitizer. It's actually homemade. That are just around the lab, and everyone's kind of a clean freak with it, which is great. And we always maintain a social distance of at least 6 feet apart. The one exception to this is when we do inject our chemicals, we can't be 6 feet apart, but this is the only time. And I'd like to acknowledge Dr. Cox, who is our department head, Dr. Martin, our advisor, Dr. Whiting, who is serving as our safety judge this semester and is also a previous advisor, and Kevin Holhauser, Andrew Linkus, Stacy Ratcliffe, the Student Engineers Council, and the VT Chemistry Department, and Steve Cope with ExxonMobil. Thank you very much. So does anyone have any questions?
That was a great presentation.
Thank you.
Do you have, what were some of the challenges that you faced when constructing the car, or something that you felt was more difficult than expected?
So as far as car construction goes this year, we did some updates from last year. We were a little bit pressed on size last year. Our reaction vessels were kind of large, and this is somewhat due to we were on a bit of a time crunch. But over last spring compared to last fall, we managed to greatly reduce the size of each of the reaction vessel holders. So going from pretty bulky secondary containment vessel down to much more compact and more accurate secondary containment saved a lot of space on the car. We did a lot of rewiring and made it much more organized. So if any wires get out of place or need to be replaced, or for whatever reason, any updates need to be done, then that is much more simple to do now. And everything's labeled accordingly, of course. As far as challenges, logistically, this year, probably the biggest challenge has been having to reconcile the person limit in the unit operations lab. So in the upstairs lab where we do most of our work, there's a 5-person limit. And in the downstairs lab where I am right now, we have a 10-person limit. We have 14 people on the team, so this makes it a little tough. We can't do full team meetings like we have in the past, except for we do a quick Zoom call once a week just to give updates. But other than that, all of the sub-teams, which we have 3, we have a battery sub-team, a chemistry sub-team, and a control sub-team, each meet twice a week independently. And each sub-team is less than, is 5 people or less. So this maintains the the maximum number of people allowed in the lab at all times. But just working around everyone's schedules and trying to do so safely took a little bit of planning, but everyone's been really successful so far, and very happy about that.
Good to know that the Corona curveball couldn't stop you. That's
yeah, that's an eloquent way to put it.
But yeah, that's all the questions that I had. I'd like to say that we're at 10 minutes until the first run. 10 minutes until the first run.
And again, the first team up will be Stony Brook University.
And then I guess I have a question for Matt or whoever figured out how to do the screen sharing. Do we have the option to get Stony Brook to show off the car while it's running, or put it in spotlight mode?
Yeah, I'm surprised Harpreet isn't back yet. I would think he would be able to get that all set up. I might shoot him a message.
Okay, so the competition will begin in 5 minutes. I think we had one more question for you, Dell team. So we would like to pull you guys into a breakout room for a quick second, and then we should be good to go. Just give me 1 second. Delaware, if you guys mind joining the breakout room.
I think we need to be sent back. I just got kicked out of the room.
Yeah, for some reason there was a time limit.
Okay.
Time.
When do they run? We don't need to put pressure on the team for this, I think, right now.
Yeah, so
we're third.
Yeah.
Okay.
So I'll put you guys back in the room. Sorry about that.
No, it's okay.
How are things going in the main room?
Is that directed at me or?
Just general, whoever wants to talk.
Sure. I'm in Hancock Hall, and the atrium of it, and it's quieted down a little bit, meaning that Virginia Tech's probably doing some more like work or chem trials or.
Oh, sorry, I'm back. Hello.
Okay, great.
Yeah, were you talking about something?
Or just how are you doing? So we have.
I'm doing well. Thanks for asking. Yeah.
See, Steve has joined. Hi, Steve.
Is Dr. Martin here?
Yeah.
How you doing, Dr. Martin?
Fine so far. I'm wondering how Skip is doing. It's pretty early for him.
Yeah, it's very early. I think they're in a breakout room right now. I'm gonna send a message to the breakout.
Is that one on?
Joni Brooke, do you guys mind standing by for a couple minutes? Because I think the judges and the regional safety coordinator, they are in the breakout room. They're discussing one concern they have. But you guys can set up your car, and once
it's kind of already set up, so.
Okay. Are you guys able to wait or no?
It'd be best if we go now, technically, because our venue is pretty. But yeah, how long would that meeting take?
I'm not 100% sure. Oh, I think you dealt that they're coming out so that I guess we can start the run.
Let me just check.
Show the car.
Can you guys show the car from a side view?
Is that okay?
I would push the car back a little bit. Just, are you guys using the base, the center point of the wheel as the measuring point, or?
The front of the platform.
Front of the platform. Okay, gotcha.
Yes. Our reference point is the end of the tape. So instead of this front part, it'll be the later part.
Gotcha. Okay. All right, great. I think the rest of the chemical committee team is joining. So you guys are in spotlight view. Tim, Skip, Dave, Robert, the run is about to begin for Stony Brook.
Can we start any time?
You guys should have a team member taking time. So just start a stopwatch, and then you guys have 2 minutes.
Okay, ready?
And Stony Brook's 5G LTE is off. Making good pace so far. Making its way down the line to 13.7 meters. Let's see how that chemiluminescence reaction works with their iron air battery.
And I see we have a number of new people on the call, so just want to welcome everyone to the 2020 Mid-Atlantic Regional Conference ChemiCar competition.
They're about at the 4th meter point right now. Have about roughly 1 minute and 30 more seconds on the clock. Seems like it's veering off just a little bit, but shouldn't matter too much in the grand scheme of things. Oh, and we have switched view to the other camera.
Yeah, but this is the view.
From my end, 1 minute and 10 seconds are down. Oh. That veer to the edge may be more and more of a problem, but we have to wait and see. Hopefully the car can make it.
Okay.
And that looks like a stop.
Oh, good job, Stony Brook.
So
fantastic performance from Stony Brook. The measurements at some point.
We're gonna get a measurement?
I think they bring the measurement stick now.
Oh, okay.
Yeah. So I think they're using the platform as the point of reference to start measuring.
Yeah, that front bar should be the specification for where their start is.
Yeah.
Can you have them bring the camera over the top?
Yeah, do you like a top view, like a bird's eye view from the very top of the car? Is that right, Skip?
Yeah.
Stony Brook, camera 1, do you guys mind just showing the car from the very top? Yeah.
So what are they actually measuring the distance from?
The platform. Do you see the?
Yeah. No, I see that, but where's the line?
I think they're using the black tape as a point of reference because that's a meter mark.
Oh.
Yeah. And then they just do some subtracting to.
Okay.
From here to here. Okay, from there. This is
So,
20 centimeters.
Just want to, if there's two Zoom calls too close to each other, then you'll start getting feedback like that. So just heads up for wherever that's coming from.
Yeah, you guys might want to lower the volume of one of the cameras or one of the computers.
If you mute one of them, then it won't get feedback.
That's the 20. Yeah, this is 20 meters. 20 centimeters.
Volume?
this may be the most complicated measurement ever made at a K-pop competition.
Starting, are you guys able to just measure from the finish line?
Yeah.
I think they're using the tile as a point of reference, and then from there.
Oh yeah. It's I know what they're doing, but it's a very convoluted way to do this.
Okay, I think we see it right there. Okay.
What does that say? 2?
It looks like a
5.5 centimeters.
5 centimeters.
Yeah, 5 centimeters.
Okay.
5.5 centimeters away from a crack of an unknown crack in a large floor.
And that is approximately 20 centimeters from the 11 meter mark.
So 14.5 centimeters from the 11 meter mark.
So 11.145.
Okay, 11.45. So that's your distance?
Yes.
Okay.
11.5.
Do you guys mind, is anyone from your team able to chat that in to the group chat so we can have a record of that? It would be easy for Virginia Tech to also
11.
keep a score of it.
Yeah.
Great. So 11.45 meters.
That's 5. This is 5, right? 5.
Yeah.
145.
Yeah. So there was is that what it is? 11.45. So
11.145. Sorry.
Yeah. Okay.
145.
145. 145.
Yeah, 145. That's 9. Yeah, it's not in here.
145.
Yeah. Okay.
Apologies.
That's a great run for the first iteration. Very close to the target distance of 13.7.
Okay, so we can move on to the next team, I believe. And that would be... Which team is next? Sorry.
Hi, can you hear me?
Oh,
For Pitt?
Yep, we can hear you.
Yeah, so you're going to want to probably spotlight my camera as I'm going to be walking with the car. But for reference, we have both cameras at the end of the line.
Okay, I'll switch between the different cameras depending on which has the best view.
Perfect. So here you can see, hold on, let me. Okay, so you can see our car is on the line. We are going to use the back of this line as our starting line.
Okay.
With our car, and then we have a marker line for our green line right here as our end line.
That's 13.7.
13.7 meters.
Okay.
So whenever you tell us we can go, we are ready.
And do you guys just mind showing the car from the top view one more time, just to confirm? So you guys are measuring from the front of the wheel, right?
Front of the wheel, which is at the back line.
Perfect. Great. I think you guys are good to go. So whenever you guys are ready.
And this is Pitt with their Hydroman powered car, utilizing hydrogen as their stopping mechanism, I believe. And it's quite a pace compared to some of the other cars presented. Yeah, we're only at 16, 17 seconds, and it's moving its way straight through the track. Oh, slowing down a little bit.
Their balloon has gone flaccid.
That is one way to describe it.
We'll leave it till the stopping mech goes. It doesn't look like he's gone. We'll give it a second. All right, red turned green, so we'll measure now.
Okay.
Sounds good.
So
let's see the distance traveled.
Can someone grab the tape?
Todd, you want to just hold that?
Yeah. So we are confirming our measurement with our safety inspector. We're going to the line, and we will verify.
Thank you so much, you Pitt.
Yeah, of course. So yeah, so it's 19 point. So 19.12.
So
That's a off by 5.83 meters. Do you need to see anything, or are you okay with that confirmation?
What's the distance? And
so we were five. What was it? It was 5.83 meters short of the
So
distance.
that's 7.87 meters.
Yes.
Traveled.
Correct.
Okay. That means Pitt is in second place as of now, and Stony Brook still has the lead.
Okay.
Okay.
Do you need to see anything else from us?
No, I think we're good. I think we can move on to the next team. So you Delaware, I believe, is next. That's
yes,
correct.
That's
right?
us. So we got camera 2 at the start. You'll see camera 1's all the way at the other end of the hallway. That's at the 18-meter mark, though. So I can, or like it's about 18 meters away, but I can move it closer to the about to 13.7. I will be also recording on my phone for the non-Zoom recording just in case, and then we have a third camera that will record that will follow the car as it goes.
Perfect. I'll most likely follow the third camera then.
Okay, got it. So that's gonna be you, Paul.
My videography continues.
So you want to get your camera going? So I'm gonna go. Yeah.
Okay.
Yeah. Are we good to go whenever?
Just 1 second. Do you guys mind showing the car from a, from a top point of view? So, which point of reference on the car are you guys using for measurement?
Yeah, we're going to be using the front wheels.
Okay.
Front wheels. Okay.
Yeah. Okay. Looks good.
I would make sure that it's completely straight. Otherwise, it might veer off a little bit. So just.
They can identify which wheel they are going to measure from, but then they don't have to run the car straight.
Yeah, it looks like the left one is right on there.
Yeah, the left one is okay.
I think it's good. Officially measured.
Okay.
Okay, perfect.
Oh, well, no,
That
Okay.
might be a little.
now it looks the right wheel.
Right, you're going to use the right wheel? Is that it?
Oh, yeah.
Okay,
Okay.
right wheel.
All right.
There we go.
Yeah.
That good?
Yep.
Yeah. I think both wheels are pretty equal now.
Yeah.
Yeah.
All right, you guys are ready to go.
And we're off. This is Delaware's The Procedure car. Utilizes a collagen capsule and the seepage of acetic acid, I believe, as part of their stopping mechanism. Really new, unique, very interesting concept for a car. And it looks like it is still going. A nice, steady, slow pace. And we've reached the first meter mark. It's about 30 seconds have been on the clock.
Doing the load, how much do you voltage drop?
So it's in there it should be like 4.8, but I think our
We are having some issues.
Well, under load, it's
I don't know.
okay. It was about
It is still moving, going onwards up to the second meter marker. And about 1 minute is passed.
9-volt battery is like 9.8. With no load.
I'm totally I don't see it. So
I think the issue is another cost. I don't know that.
And we have roughly about another 30 seconds. It's important to note that the car should stop. And if not, DQs may happen.
Oh, so we're gonna have a sort of. You just have to hold it, guys. Is there a problem with going over?
yeah, that's stop.
It doesn't go. Okay. I see where that.
Okay, at least on my end, I have the timer going past 2 minutes.
I'm shaking.
Well, if the timer goes past 2 minutes, that's a disqualifying run.
What'd you say? Sorry.
Sorry, what was the time?
On my end, it was 2.23, but
On my end, it was past 2 minutes too.
Okay, yeah.
So that run is disqualified.
Okay. Okay.
No
but
big deal.
great effort, Team Delaware. You still have a chance. Don't worry about it. First run's always meant as a calibration.
At least you guys got it to run. We had a couple cars in other regions that weren't able to run at all, so
that's true.
You guys are in pretty good shape.
Yeah, fantastic performance.
Yeah. Okay. I guess we can move on to the fourth team now, and that would be NJIT.
He's gonna start. Put on mute. We're muted. So he's gonna start the car from the air, and the front of the wheel is gonna be aligned with the beginning of the blue line.
Why is it
Sorry, you
being
guys in
started
mind.
from the air?
Why?
Do you guys mind repeating what you guys just said? I wasn't sure.
He's going
going to start the car from the air, and he's going to set it down on the ground.
Are you guys? Is everyone else able to hear?
No, I didn't hear what he said. I saw his hand, but I didn't hear what he
He
said.
said he said he was going to start the car in the air and then set it down so the wheels are on the line.
No, you can't do
You
that.
can't do that.
We did it last. We did it last year.
Yeah, well, you can't do it now. You have to have the. You can't lift the car at the starting line. It has to be on the ground.
Well, the back wheels will be on the ground. The front wheels have to be up.
That's not allowed.
Will your car not run at all if it's on the ground?
Yeah, it's not gonna be able to start going.
Yeah, so basically what you do when you hold it up in the air is you are giving your car a boost, and you are not allowed to give your car a boost at the starting line.
You can try it.
Is it too heavy? Is that a problem?
Well, just the motor has to get.
Yeah, you don't have so you don't have enough torque in your motor is the issue a lot of cars have, right? And there's a statement in the rules about that. No.
Try it from the ground. Just move it.
You guys are, we're ready whenever you guys are. So it looks like you guys are using the front of the wheels as the reference point to measure.
Just try it.
We're ready when you guys are.
Ready? Going.
Oh, there we go.
There you go. And it's moving.
Okay. Trying to find the right camera.
This is NJIT's car. It's called the Highlander, and it works primarily off of a hydrogen fuel cell. Well, we may be experiencing a little bit of lag on the bandwidth, but shouldn't be a problem for the final results.
Yeah, there we go. There we go.
There we go, past another meter marker.
I'd like to nominate this car for most pressure gauges on a single vehicle.
It's definitely a very unique design, and does have a lot of gauges and measurements on it. I also really like the balloon that's sticking out on the side.
Yeah, and the sound effects.
Hey, it looks like the car has come to a stop. So is someone?
That's a 5.7.
It's at the 8 meter mark.
So did you guys say it's at the 8? So you guys are measuring from the front of the wheel, correct?
Yeah,
It looks like it's a little bit under the wheel. So it would move up the. Yes.
It's at 8 meters, exactly.
Yeah, that's close enough.
Okay, sounds good.
Okay. 8 meters for NJIT, putting them in.
I think UPIT was the second team, correct? UPIT, do you guys mind inputting your distance in the chat? And same goes for NJIT.
We can do like a little more. What do we just do?
Because we're starting from the Okay. Cancel spotlight. So I believe Virginia Tech is next.
Yep. All right. So I'll be streaming our cars run.
Okay.
And, yep. So I'm gonna go over the track quickly first. So here you can see our car, and it's starting on this white tape line. We are measuring from the front left wheel here. You can see it's directly over the line.
Yeah.
And it's on the left side of the tape. And we have it marked every meter, so just walk down all the way. And this duct tape here, since it was not super visible, I marked it with black arrows there. So we are measuring the distance from this side. This is 13.7 meters.
Okay, sounds good.
Yep, and we have a little bit of extra space on the far side, so if the car goes over.
Perfect.
Okay. All right, I'm ready to time. And Anshul, you got the video ready? Okay, so we're starting the car. Right? And we are off.
Yes, this is Virginia Tech's Paul Arona. Works off of a vitamin C clock. Slow start, but we'll see how it goes. Already on passing the first meter.
So Virginia Tech is number 5 on the run now. And then there's a 15-minute break, and then I think we go in
Yeah.
from first to last, right?
Oh,
So
do we?
At least that's what it's been traditionally.
Oh, I didn't know that.
Sorry, go ahead.
And the Virginia Tech car is making its way down at a nice pace. Well, seems to be veering off just a little bit. But we're past the minute point and getting closer to the end goal of 13.7 meters. And let's see how they make it. Roughly 1 meter away, maybe overshooting it just a bit. Oh, wow.
Wow, incredible.
And it looks like it is still moving. And is that the stop?
And the car is stopped. I'm going to press the power down button here. And unplug the battery. And we will measure the distance now. So, could someone go grab the measuring tape?
It's a tremendous run. Good job.
Thank you. Appreciate it.
Great run by Virginia Tech.
Oh, she's probably more visible from the other side.
Yeah.
Yep, we lined up the front of the left wheel here. Yeah, so as a reminder, we are measuring out to right here.
Yep.
Yeah, so 5 centimeters. I can do a aerial view if you want to see that as well. So 5, maybe 5.5. Yeah, I think that looks like 5.5.
5.5 centimeters. Yep.
Yep. All right.
Okay.
Well,
do you guys mind inputting your distance in the chat just so Matt, I believe, is keeping the scores, can have it all in the spreadsheet?
Yes.
Great run, guys.
5.5 centimeters.
The excitement out from here.
That would be 13.645 meters traveled then.
Yep. Sounds good.
Also, I had a question on the pit one. I thought they had said that that was 7.87 meters to be off by 5.83, but they input a different distance in the chat.
You are correct. That was my bad typing it. You are correct.
Perfect. Thanks.
So pit's distance is 7.8?
7.87.
7.87.
And so far after the first round, we have Virginia Tech in first place with a distance of 13.645. Stony Brook in second with a distance of 11.145. NJIT in third with a distance of 8.02. And Pitt in fourth with a distance of 7.87 meters. And then Delaware with DQ in the first round, but can definitely.
There's definitely a chance in the second go.
Absolutely.
Matt, do you mind sharing your screen just so it's visible for everyone? I think NJIT has a question about having the car be on the starting line. Let me see. Delaware, yes, the order for the second round is the same. So I believe now we can start the 15-minute break.
I had a question for you. We got a video from AICHE that we were asked to play. It's about 12 minutes long. I was wondering if you wanted us to do that now during this break or at the end before the awards, or.
Yeah, we can play it now during the break, and then maybe we can re-adjourn at 11:50. Does that sound good?
Oh, that sounds great.
11:50 Eastern.
Yes. Do you want me to go ahead and play it now then?
Yeah. Thank you so much.
I think I enabled my screen sharing so that you can hear the sound over my computer, but let me know if it.
Professionals Committee, we're very excited to join you at the 2020 Regional Student Conferences. My name is Owen Jappin, Chair of the Young Professionals Committee. I'm joined by two of my fellow YPC leaders, Donna Bryant, our past chair, and Shelby Mills, our vice chair. To kick us off in our conversation today, I'd like to pass it off to our vice chair, Shelby Mills, to share with us who are the young professionals.
So to answer your burning question, who are young professionals? The answer is you are a young professional. Once you graduate with your degree, that is immediately what you become. As crazy as that may seem, I know I did not feel like one once I finished, but that is exactly who we are. It's anybody from the day after graduation to 5-10 years into their career, trying to find a new career path, a new field, either just advance their professional skills. Graduate students fit in here. That was a big deal for me as a graduate student. We include graduate students, new to the working world. So your first job, whether it's industry or academia, we are a wide mix of career fields and backgrounds. And as long as you have a Chemie degree and you're under 35, you are considered a young professional.
Great, thank you, Shelby. And continuing on that thought that we are such a diverse committee of members, we organized the YPC into several different subcommittees and working groups for different topics of interest. So one of them, as you can see on the screen, we have the programming subcommittee, which organizes the different sessions and content for young professionals at the spring and annual meetings every year. Our local sections committee, which assures that the local sections located not only throughout the US, but globally, Keep in mind content that's relevant and exciting for the young professional demographic, and also supports the formation of specific young professional local sections. Our publications subcommittee creates content for not only the YPC newsletter, keeping our members up to date via email on all of our activities, as well as other media publications throughout AICHE, throughout AICHE's platforms. Our next subcommittee is the Retention and Recruitment Subcommittee, which assures that we're constantly able to offer the right content and development opportunities to keep young professional members involved in the Institute and continue support growing their career. Our last and newest subcommittee, about 4 years ago, a member of the YPC had the idea to form a beer brewing competition and host it at the annual meeting annually. As such, it was so well received that it became a large enough undertaking that we formed a subcommittee specifically to promote and organize this at the annual meeting every year. If you're interested in any of these subcommittees, or if you have an idea, such as the beer brewing competition, kind of taking a new direction with the YPC, we'd be very excited to hear from you. Feel free to reach out to us at ypc@aiche.org, or join our YPC mailing list, which will be circulated after this video. A bit of news that we'd also like to share with everyone is that as you are a graduating senior and becoming a full professional member, your membership dues are gifted to you from the AICHE Board of Directors. This will grant you not only access to involvement in the Young Professionals Committee, but access to all of the Institute's different member benefits, including AICHE's Career Tips ebook, a monthly publication, CEP, Chemical Engineering Progress, which gives you access to the top professional development skills, the best of equipment series, and the most beneficial technician chemical engineering skills. This will also allow you access to AICHE's webinar bundles on valuable topics including leadership development, process safety fundamentals, communication success, and life skills. To kind of get a feel, to get a feel for how to be involved in the Institute overall, I'd like to pass it over to our past chair, Donna Bryant.
Well, thank you, Owen. In addition to becoming involved with the Young Professional Committee after graduation, there are different committees that you can also become involved with in other different divisions. And so it's all based on interest in what type of things that you would like to do. So we have other groups that are focused on a particular groups of people and supporting of those groups of people. So women in chemical engineering, minority affairs, LGBTQ+, disabilities outreach and inclusion communities, as well as we have different divisions that focus on different technical subjects, such as fuels and petrochemicals, management, safety and health, environmental separations, and there's a lot more. And so those are different groups that you can come involved with. And in addition to that, virtually, you can become involved with the AICHE Engage platform, as well as social media that AICHE has. So I always get asked, so why did you join the YPC and why did you continue to stay involved in AICHE after graduation? And it's a wide variety of answers. A lot of things went into it, but basically it comes down to what I wanted to do after graduation and the type of enjoyment that I get. So I ended up going to a conference after graduating to continue to go to sessions and continue to learn and advance myself technically. And then I ended up meeting a bunch of young professionals actually at that conference and then learning a little bit about the Young Professional Committee. So I immediately got involved and joined the programming committee that Owen was talking about before. And that committee actually is the one that puts together sessions and different activities that happen at the different conferences. So I actually did the planning for one of the conferences that happened in San Francisco, focused on sessions for young professionals. So that involves sessions around people presenting research, both for undergraduates and then also sessions specifically for young professionals. And so I really enjoyed that, so continued to get involved. and wanted to continue to look at some of meet the needs of young professionals. So one of those things is around, we had a need to make sure that people had professional pictures of themselves. And so we ended up coming up with the idea of having a photo booth at the different conferences for people to be able to participate in and make sure that they have a good picture for their LinkedIn profile. And so we were able to make that happen, and members are able to do that now. So I've really enjoyed my experience with AICHE and the YPC, and I have benefited from it from a networking standpoint as well as just developing myself. So how about you, Shelby? Why did you join YPC?
Thanks, Donna. So I joined YPC my first year of graduate school. So during my undergraduate degree, I was a student leader like many of y'all and many others in AICHE. And when I started graduate school, I wanted to continue my involvement with AICHE because it was such a big role and group in my life. So I went with the current leaders, because I still knew them, to a student conference, and found out actually at the student career fair at the meeting about YPC, and that the young professionals included graduate students, and that is how they fit into AICHE as professional members. And with that, AICHE is a volunteer organization, so all you have to do is say, I'm interested and I want to get involved and I volunteer, and those are like the magic words. And so from there, I was able to do things with the local sections in my area and across my region. I worked with the young professionals publications, putting together the newsletters about upcoming events and activities happening within AICHE for young professionals to know about. I've done things with the retention and recruitment, because one thing that I've really enjoyed as a young professional is you can be a judge at student competitions. So whether you enjoy posters and research or KimiCar or the global student video competition, they're always looking for volunteers to help judge the current students, so you can stay involved that way. And just growing my network and attending the conferences and meetings, meeting people in my field, knowing what's going on, meeting people in other areas of chemical engineering and making those connections and friendships. And that really helped pay off when I was going through a job search recently, getting help putting together resumes and just tips on like applications and interview skills. So it's been such a blessing, and I encourage you all to stay involved as well. Owen, what is your story with AICHE, and why did you continue your involvement?
Thanks, Shelby. To me, it just seemed like the logical progression after being involved at the student chapter level. So after graduation, I attended my first annual meeting and have met so many other people through the Young Professionals Committee. They've really been lasting friendships, both socially but as well as professionally, and helped inform my decisions for different career paths that I've maybe shifted through over the last 10 years or so. And really, it's held up similar to the relationships I built through the student chapter or involvement, not only within my university, but as well as going to the different regional conferences like all of our viewers that are at today. It's really, it builds your networking opportunities as well as helps educate you and kind of gives you those kind of in real life practical skills to help plan your career and kind of forge your path forward there. But I think the common thread between all of ours is that we've all had maybe different avenues that have brought us in, but these are just three such views. And I think one of the main topics that we've been discussing today is that we are a very diverse committee. So there's probably hundreds or infinite number of reasons that people might join, the different benefits they can gather from the Young Professionals Committee. So we encourage all of our viewers today, find your reason. So we look forward to having you involved after your graduation. To find out more about the organization in the meantime, please feel free to visit aiche.org/YP. And if you have any questions at any time, please feel free to reach out to any of us at ypc@aiche.org. Hello, on behalf of the Young Professionals Committee, we're very excited.
All right, thanks everyone for watching that. Have the scores up here for reference, and we'll be getting started again in a couple minutes.
It is awfully quiet. What is going on right now?
Where's Paul?
We just got ready, and now we are ready to run our car again.
Okay, great. Paul is such a great MC, I must say.
He was wonderful last night.
Yeah, Paul, can we recruit you for the annual student conference? I think he's away.
We can also do the same way.
I can hold this, yeah, as previously.
Okay. I think we're still getting questions from NJIT. If we want to, maybe we can address them later because we're about to begin.
Yeah, we can always jump into a breakout room after the next run to explain the rule.
Yeah.
So, are we ready to run, or should we wait a few minutes?
You make this big screen. First, just make it big. I think that's where it's from. Start. Because he was easier before. Okay.
So before actually wanted to save, but then you show the
on the side, right? Are you good to go? We'll start. I think you're muted. No.
Okay, so I think we can get started now. Are you guys using the base of the wheel where it touches the ground as this? Or no, you guys are using the platform, right?
Yeah,
okay.
Platform.
Okay, we're ready whenever you guys are.
Okay. I'm ready?
Yep.
Okay. Sorry about that. Small break. I believe this is Stony Brook and their chemiluminescent car. Yeah, see ya. And it's moving along nice and steady.
It looks like it stopped.
And yes, is that your stop?
Yes, I believe this is our stop now.
Okay, great run, guys. Would it be possible to start the measurement?
Let's see. Just the line. Is it line now?
This one is line up, yes.
Okay.
Yeah, did you pin that video? I can't see it that well.
Yeah, the Stony Brook University 1 video.
Yeah.
Yeah. Would you like to get a closer view? Like,
So the front of it.
Yeah.
So I believe they're measuring from the starting line. So that's
Yes, from the starting line.
okay. So that's it looks like it's 1 meter and 52 centimeters or 51 centimeters.
50.5.
50.5. Okay, sounds good.
Yes.
So it's
1.55
here, right?
or 1.05, right?
Well, 150 is
Right. Yeah.
so 1.55. We will put that in the chat as well.
I think isn't that 1.505?
Wait, where were they measuring from again?
They're measuring from the base of the platform of the.
From the front, the back part, from the front part, right?
From the front part, yeah.
So isn't it 1.100?
505.
So 150.5. Yes.
Not
No.
1.505, right?
505, not 55.
Oh, yes.
Yeah, it does look like that it's around 1.51, but I could be mistaken.
It looks like, yeah, 1.51 and 1.52, yeah.
Okay.
Yeah, I think 1.51 makes more sense.
Yeah.
I agree. So 151. So 151.
Okay. 1.51.
Okay, great. Thank you so much.
Yep.
I'd also like to nominate Stony Brook as the most complicated measuring system. Once again.
Yes.
Thank you guys. That was a great run. I think we can move on to the next team now, and that should be Pitt, if I'm not mistaken.
And so Stony Brook will be keeping their score from the first round, which retains their spot in second place for the time being.
Yeah. Try to find where Pitt is. Okay. So found one camera. I believe they're setting it up.
Hello, can you hear me?
Yep,
So,
we
yeah,
can hear you.
You're going to want to follow my camera as well.
Yeah, gotcha.
Great. Always nice to see the dynamic view.
Of course. Try to give you the best angles. Whenever you're ready, we are ready. Oh, I'll give you the walkthrough again. We're using our wheels in the back line, and we're going all the way to the green line.
You might want to. So,
Yeah. Can you hear me? All good?
We can hear you.
Okay. So, you want to start it up, play?
Yeah, you want
Okay. So, also, we definitely had some propulsion issues. So, we are not expecting this to go very far, but we're going to give it a shot. So,
no problem.
After you.
That's the important part.
Yeah. It's not going to get off the line. Oh.
Don't speak too soon. Making a great start so far. This is Pitt with their Hydroman Hydrogen Balloon 4.
What is wait, guys. I told you,
Today.
So, yeah, we will measure from here and get you. So yeah, Clay, you want to grab the. Either way, you just measure from the. Yeah. Come with. Yeah. Come. Oh. We're gonna measure like everyone else this time.
Okay.
So that's 16 feet and 4 inches, and we'll convert that to meters for you.
Okay, perfect. Thank you so much.
Yeah, and to confirm, you're at the back line there.
Great, perfect.
So give me 1 second, I'll get that for you.
I can stop the spotlight view. And as Pitt is entering their distance, Udell, are you guys ready?
Yep, we are good to go.
Okay.
Same setup, one camera here, one camera following on, and then one all the way at the back.
Sounds good.
Going for the front wheels again. Do you want the top angle? I think our other camera has that.
You guys.
I think that's good. That's good.
That's good. Okay.
Yeah.
So,
yep.
Yeah.
All right. Good to go.
Yep.
And that's not good.
we may be experiencing some technical difficulties with the start.
Squeeze one. We can. Okay.
Give it time to reset.
Yeah. I believe one of our wires came loose.
Yeah.
Oh no.
It's time to go work.
Sorry, one more time to reset. I think technically.
Yeah. I mean.
Do that, but it's more.
Yeah. I bet you that came off.
Yeah.
That's so weird. I don't know if it's gonna go.
Not gonna go.
Yeah, it's okay. I mean, it happens.
Did we see if it stopped?
We might do the click of it stopping.
That's the thing. The first time we only started, and the second time we don't.
Yeah.
Super score?
We're going for a super score there. If you could combine the two runs.
No worries. Thank you, UDEL team, for putting all the effort. Still was a very interesting car, and you guys had a great poster as well. So, congrats on placing third for that. Okay, so I think we can move on to the next team now, which should be NJIT.
Yeah. What is you think
Trying to figure out which camera to follow.
How's Aspen training going? Okay. I saw you were on.
Dr. Martin, I'm going to put you on mute. Sorry about that.
And this is NJIT setting up their car. And we're off. Good movement by NJIT. A little bit of lag from the camera, but we can still see what's going on. Making a nice slow and steady pace, but passing through one of the markers. Looks like it's veering off just a little bit. That shouldn't be too much of a problem.
I count 6 gauges.
Yeah.
Is it
And
6 or 7?
what NJIT? What does the balloon do? Does anybody know what the balloon does?
I think it's part of their stopping mechanism, but maybe better to ask them.
There's one on the other side too of the car.
Really?
Yeah.
There's a balloon on the other side?
I think so.
Oh, and we have just passed the 10-meter mark. 3.7 more to go. Now this might be a close one. Oh, and it may have overshot. Unfortunately, they are past the target distance.
Well, they can still stop this as long as the time is okay. Oops, see, the balloon went flaccid.
There we go.
Perfect. Okay. Do you guys mind measuring the
Oh, you're right, Dave. That's two
difference?
So I just slowly insert gas into the system. Okay.
Thank you.
So the front of that black tape is what?
It's 16.69.
I think that's the
16.
yeah, 16 meter mark.
Okay.
2.99.
Whoops.
Okay, I guess the 1 sec.
Bandwidth is always a struggle.
For sure. Okay, so I think the final distance is 16.49 from NJIT. It was very close to the.
Are you sure? Oh yeah.
Oh, 60.69. Okay.
Yeah, 6.9, right? Yeah. Okay.
Wait. No. Hold on. Show it again.
Show it again.
Oh, okay.
So the distance should be measured from the end of the line. So where's the 16.9 from?
The end of what line?
The end of the
tape.
finish line, because they went past the finish line.
Yeah, so they just need to, they have 16.6.
Hello, can
Oh, okay, so they have to
our
subtract
distance is
13.7 from that.
16.49.
So they
Okay,
have to subtract 13.7 from that.
Yeah.
Right, right.
That's right. But can you show the picture? I can't, you keep moving it, I can't see anything.
Show it again. Yeah, I think it's like the camera video keeps going in and out. Okay. Oh, it is 4.9.
Okay, 4.9. Okay, there we go. Thanks.
Oh, gotcha. So that was the 15 meter mark, and they were using
that was a 16 meter mark, right? Oh, 15 meter mark. Okay.
The blue line was 15, and then the black square was 16, and that's what they used to measure from.
Yeah.
Next to the car. Okay.
So 16.69 minus 13.7.
Yep. Okay. So next up, Virginia Tech, our last team.
Hello again. So I'll just give a quick walk of the track one more time. So car on the line. And I have every meter marked out and measuring to the tip of the black arrows on the far side of the duct tape there. All right, everyone ready to go? Okay.
And the Virginia Tech team is off. Going a little slower, but passing through the first meter marker.
I think it's picking up speed now.
It did the same thing last time.
Yeah. And it's very much in line with what the velocity profile, or I'm estimating, but I think you guys provided a velocity profile in your poster. And
yes.
It did show that it starts off slow, but then it picks up speed, stays at that speed, and then decreases, obviously.
You hope, anyway.
Right. Yeah.
Yeah, it's all about controlling the chaos of chemistry.
Yeah.
Yes.
Oh, so Paul, I think you were away when we were talking about this, but I think we're trying to recruit you for the annual student conference, because I think we think that you're doing a great job emceeing the event. So
Thank
if
you.
you're interested, yeah, let us know.
You cut out a little bit. You could always message me, or I'll message you later. I appreciate it. I'm trying. It's Chemi Jeopardy took a lot out of me, so.
You did so good at Chemi Jeopardy, though. that was a long ask.
Yeah.
Ooh. And we're about, or it's going through, slowing down a bit.
Oh, it still wants to go.
Yeah, hasn't given up yet, but we're getting close to the line.
How's the time?
That you may have to ask Virginia Tech themselves on that.
Time stopped. And I am powering down.
I think the time is okay.
The battery. All right. So we can measure. Where's the measuring tape?
Still great. Not as good as last time, but still pretty good.
Appreciate it. Okay. So here's the better view, and from the wheel that we're measuring from. Okay. So measuring. Let's see, take it from the end here. I think this time. So is 0 out to 16. I'm just gonna get an aerial view so y'all can see that. So maybe slightly. Yeah, that's vertical down from the wheel and about 16 centimeters from the target.
Okay.
Yep.
All right. Thank you very
Matt,
much.
thank you guys so much. That was a great run, everyone. Matt, do you have the final scores compiled?
Hey, Virginia Tech, can you just show the car one more time for me, please? And the measurement. Yeah. Oops. Hold on.
Yep. So there's the end there of the tape.
Yeah, move it back. Just can you move it up a bit? I can just move it up a bit. Yeah, good. Okay, thanks. Okay, thank you.
And so I can go ahead and present the final scores here then.
Yep.
So in first place, we're going to have the Virginia Tech Corona car. Second place will be Stony Brook 5G LTE. And third place, the NJIT Highlander. The overall distances.
Awesome. And the fourth team is UPitt. So usually I believe we have 5 qualifying teams from the from Mid-Atlantic, but I think now 4 teams will be proceeding because one team wasn't able to move forward to the next round. So it'll be Virginia Tech, NJIT, UPitt, and Stony Brook. You guys are going to the annual competition. And just as a reminder, the poster competition winners were first place Virginia Tech, second place NJIT, third place U Delaware. Okay, awesome.
Good job.
Congratulations, everyone.
Congrats, everyone.
And thank you for participating.
Yeah, great job to Virginia Tech for putting this all together. For the, I'm extending a thank you to the Chemical Committee for being here. Also Tim Raymond for being the Regional Safety Coordinator, and all the teams for your enthusiasm and keeping the momentum going for this competition, because that definitely pushed us to figure out the logistics of a virtual competition. And thank you guys so much.
Okay.
Yes, Daniela, Virginia Tech didn't win both. Their team was great, so I think it was well deserved. Okay, thank you guys.
Okay.
Are we all done, or we get into a breakout room or anything like that?
I think the issue, Virginia Tech, do you guys have any questions about the rules? Oh, not Virginia Tech, NJIT. Do you guys have any questions about their? Yeah. I think Robert pointed out that there was a rule 12.7, I believe that.
Yeah, Dave found that rule, 12.7. So 9.3 and 12.7 are both pretty explicit.
Yeah.
Yeah, so that rule, we looked at that rule and it's, yeah, you cannot lift the car. But we feel a little bit bad about being let know that the distance is going to be lower than 15 meters just the day before the competition.
Yeah, I think that was just a difficult call across the board. We had another region where that decision needs to be made.
That also violates rules, right?
Well,
what rule are you violating?
Well, it's a little bit complicated because
6.1 about the distance.
I think we just have to take into consideration that every team is at their own campus, and we just have to abide by what sort of track is at every team's disposal. So if the maximum distance was 15 meters, we instead of defaulting to 15 meters, we had to pick a rule distance that was between a certain interval, just so there was still an element of, requiring the teams to do some sort of a calculation to calibrate their cars. And we understand that calibration is usually done between 15 and 30 meters, but this is the opportunity for us to, sort of be flexible and be understanding of the different circumstances that come with the restrictions of running a virtual competition.
But I do have a question. Yeah, so the 15 meters, not being at 15 meters, is not stated in the rules. But we're also dealing with a situation where we are not all at one site, and so if there are facilities that do not have the capacity to go 15 meters, then what do? Do we stop the competition?
Well,
I'm trying to
team,
understand what the concern is.
If the team can't find a hallway that's 30 meters long, then I don't see why they should participate.
Wow. Interesting.
Well, I think one way we are trying to mitigate this from happening at the annual competition is that now that we have a bit more time, I'll be reaching out to all the winning teams and requesting them to resubmit the track dimensions. And if there is a track that is 15 meters, we're going to request that they find another spot, because obviously all the calculations are being done between the 15 meter and the 30 meter mark. So we want to try to at least get in that range for the distance. So we are making the efforts to, figure out a solution.
Yeah, NJIT, I think you need to understand a couple of things. One is every school and every state has different restrictions on what you can do. So for instance, we have social distancing rules, which most of the teams here would have violated, okay? And so we could say, oh, well, you can't, you're not following, government regulations, so here you can't participate. I think you need to be a little bit forgiving in these times about what can and can't be done at each school, because each state has different regulations, right? So they may not be allowed to run anywhere else just because of state regulations. We have that issue in Oregon, okay? So everybody's dealing with, I think, just in unusual circumstances. I think nitpicking at the rules is probably not the right thing to do right now.
Yeah, I think another thing that I can add is that for one of our teams, only 2 lab mates were allowed to be.
Yeah, you nitpicked our starting procedure rules, but you don't nitpick the.
No, that's not nitpicking. That's a firm rule, no matter where you're running, right? Okay, it's very clearly stated in 2 places. So that's just that you didn't read the rule. That's a different story. That's not an individual circumstance of the day of the competition, right? I think there's 2 very different things here.
I guess what the point I was trying to make was that in certain universities or certain states, only 2 members of a team are allowed to be in a lab. And, if we wanted to really standardize everything, we would have to take that into consideration and then ask every team to abide by that rule and only have 2 members in each lab. So that it just becomes very granular and very difficult to, moderate. So we're just requesting that everyone is a little bit more flexible.
Okay.
Yeah, and I think the goal of the competition, right, is to be able to compete and compete as fairly as possible, and that's what we always strive for with all the rules. And so, there's a lot of things happening this year at all the different regionals where we have to be a little more lenient. And so I think I hope you understand that, and I'm sure you do. But we're not going to be able to be
a little bit more time notice would have been good.
Yeah, I understand. But for instance, I can tell you at our school, we were set to go at one place, and then the school comes back and says you can't do it there. Okay, and we didn't get a lot of notice for that. So things like that are not able to be controlled at this point in time. And honestly, states change from week to week about what they allow you to do and not do. So it's a dynamic situation. That's all I want to say. And we're trying to be as cognizant of that as we can, and also let as many people run as we can, because you're all putting in a great effort to be able to do this under, you know, the conditions that you're being put under by the state and the government and whatever, and the pandemic in general. So,
Anyway, all I want to say is that I'm proud of you, of all of you guys, that basically this competition was set up to allow you to test your capabilities for doing engineering on the spot. And everybody who ran today did an excellent job. So for me, that's the more important situation, is that you guys were able to rise to the challenge. And so I commend all of you for what you did today.
Thank you.
Yeah, I just want to chime in. Pitt is super appreciative of everyone's efforts today and making this a competition, and just really appreciative of everyone who AQ that helped us and our safety advisor and just everything. And couldn't be more grateful for all your help today.
Thank you.
Thank you.
All right, we'll see you all at the annual student conference. So we're excited about that. And thank you again to all of the cars that ran today, all of the teams. You guys did amazing. And we look forward to seeing you soon. And thanks again to BT for hosting. Great job, guys.
Thank you, everyone, for taking time out of your day.
All right.
Thank you guys so
Hi,
much.
Gina.
Thanks, everyone.
Hello, Gina. YA saying hello.
Hi, Dr. Lou. Hope you're doing well.
I'm watching on winning.
I met one of your teaching assistants last night. He was doing the poster competition or the paper competition.
Oh.
I heard you're doing Aspen this weekend, right?
Yeah, lunch break. I'm watching the finishing touch.
That's awesome. And BT won, so that's exciting.
I actually take the screenshot on the winning table, the score table.
Yes, I'm sure Matt would send it to you too.
At 1 o'clock.
I can do that.
Perfect. You should. Yeah, thank you.
Logging off.
Bye, Dr. Lou.
Bye.
Bye, Dr. Lou.
Gina, I just want to say this was a hockey competition, so BT did a good job.
Yes, he did. And now we can go watch Hokies beat UNC.
Wow.
Are you guys playing today?
Yeah, we're playing right now.
Oh, so some of us who are not rich enough to get those fancy channels, right? We don't get to see it. We are poor folks.
You got to step up, Robert. Pay for the subscription there. So.
Oh my goodness.
Hey, it's on ABC. It's on normal television. You can watch us win. It's cool.
It's on ABC?
Yeah.
Oh, okay. I will check you guys out. Don't embarrass me though.
I would never. Paul would never. We wouldn't do that.
Yeah, Paul and Matt, great job, guys, by the way. Yeah, I think it ran really smoothly. Couple hiccups, but that's a given. But yeah, overall great coordination and really great job mitigating any sort of conflicts that came up.
Good.
Yeah.
You too, Harpreet.
We really appreciate all of you guys' help as well. Super helpful in coordinating everything and making sure everything ran smoothly.
Right.
Group effort.
Yeah, Matt, don't forget to send me the logic. I'm really interested in that. And Paul, if you want to get involved in the annual student conference, let me know.
Sure. If you think I'm a good fit, I'll be more than happy to in any way I can help.
Don't worry, Paul. If you mess up, we'll just fire you on the spot, right?
Wow,
yeah, they're not very forgiving.
Robert's tough.
No, Paul, you did an outstanding job. Thank you so much.
Yeah.
Thank you.
Thank you, everyone.
All right, see you, everyone.
Bye,
guys.
Yeah, bye-bye.
See you guys. I'm gonna go get lunch.